the integral of e to the power of x sine of x dx. So here we see e to the power of x, so we see an exponential. And then we also have sine of x, and sine of x is trigonometry. The circle at the very top, this one, is always a u. So we know that u is equal to sine of x. And the derivative, du over dx, is going to be what? So the derivative of sine of x is cosine of x. So du is equal to cosine of x dx. And how about the dv? So dv is going to be equal to e to the power of x and also dx, right? So because this is the same as saying sine of x, e to the power of x dx. So we chose sine of x to be u, so the rest will be dv, according to our formula here. So dv will be equal to e to the power of x times dx. To find v, we need to integrate. So we have the integral of e to the power of x dx, which is the same as e to the power of x plus c. So using the formula, we have the integral of u dv. So this is the integral of u dv, and that's equal to u times v. So u is sine of x times v, right? And v is e to the power of x plus c. But you always ignore the plus c. So we have e to the power of x, then we minus the integral of v du. So v is also e to the power of x, and you ignore the c, and we have du. And du is cosine of x dx. And to solve this integral, we have to use integration by parts again. So looking at our acronym, LIATE, we have an exponent, right? We have an exponent, and then we also have trigonometry. So the first circle at the very top is going to be the u. So let u1, let's say we have u1. u1 is equal to cosine of x. So du over dx. The derivative of cosine is negative sine of x. So du is equal to negative sine of x times dx. How about dv? Oh, dv will be e to the power of x dx. And to find v, we need to integrate. So the integral of e to the power of x dx is the same as e to the power of x plus c. So we have this integral, which is the integral of e to the power of x cosine of x dx. And that's equal to u times v, right? So u1 is cosine of x times v, which is e to the power of x, minus the integral of v, which is e to the power of x, and du. And du is going to be negative sine of x times dx. So this is the same as e to the power of x cosine of x. And if you bring this negative sign outside of the integral, you will have a positive sign. So we plus the integral of e to the power of x sine of x dx. Now let's go ahead and substitute this part into this part. And we're almost done. So let's move this up here. And as you can see, if we minus this expression, we will have, this will change to a minus sign. Now we have an equation, right? The integral of e to the power of x sine of x dx is equal to all of this, and you also see itself, which is the integral of e to the power of x sine of x dx. So all you have to do in this case is add the integral of e to the power of x sine of x dx to both sides of the equation. So here we will have 2 times e to the power of x sine of x dx is equal to, this here is e to the power of x sine of x minus e to the power of x cosine of x. And then this will be 0, so plus 0. Here we will divide both sides by 2. So we have the integral of e to the power of x sine of x dx is equal to 1 over 2 times e to the power of x, and we have sine of x minus cosine of x. And don't forget to plus c as well, because this is the integral, right? So the antiderivative must have the plus c. And this right here is the answer.